Good day, everybody. How are you all? Today, we are going to work on a problem on binomial probability distribution. So I'll share my computer screen with you. "59% of employed adults believe that if they lose a job, it will be easy to find a job with similar salary. Suppose that 30 employed adults are randomly selected. Find the probability that exactly 3 of them believe that it would be easy to find a job if they lose current job." Okay, so let me clear that up. That is a current job. Okay. Next, find the probability that more than 2 of them believe that it would be easy to find another job. And part C, do part B using normal approximation to binomial distribution. So let's take up part A, solution. So exactly 3. So we are going to use TI-84. So in TI-84, we will press the key second first, then verse key, which is in the third row. Then we will scroll down with the down arrow key to binom for binomial distribution, binom PDF. Scroll down to binom PDF. Okay. Now, why are we doing a binomial distribution? Because 59% of employed adults believe that they will get a job if they lose one. So either they believe that they will get a job or they do not believe that they will get a job. So the two outcomes are believe in getting a job, and the second outcome is not believe in getting another job. Okay. So that's why we are using the binomial distribution, because there are two possible outcomes. Okay. And we are using TI-84 calculator. Therefore, we'll use the binom PDF function in the calculator. How do we find that function? We press the second key, then the verse key, and then we scroll down to binom PDF. So let's do that on my TI-84. Second button, then verse button, which is in the third row, then scroll down to binom PDF and hit enter. So in binom PDF, number of trials they're asking for. And that's your N. That is equal to 30. Your P, probability of success, is 0.59. Your X value is exactly 3. So X value is 3. Then you will scroll down to pest, bring your cursor on pest and hit enter and enter. Okay. And whenever you are on pest, you have to hit enter twice. Okay. So number of trials is 30. Probability of success is 0.59 and exactly 3. And paste, enter and enter. And the answer is very small. So P X exactly equal to 3 is very small. It is 2, it cannot be 2, probability cannot be greater than 2. So it's 2.9 E minus 8. What does it mean? In practical sense, the number 2 will be the 8th place after the decimal. 5, 6, 7, and then 2. That's your answer. It's almost zero probability. Okay, so that was part A. Let's move up a little bit, create some space. Okay. So this is part A. Now part B. We will do part B using binomial distribution. So part B. So we will do part B here. Okay, using binomial distribution. Binomial distribution. Distribution. Okay. So basically we want to find out probability of x greater than 2. That is P3 starting from 3 plus P4 plus dash 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 P30. As you note that we have to find these individual probabilities and add them up. So we will use the probability law of complement events. So complement event to x greater than 2 is x less equal to 2. So we know probability of event A is equal to 1 minus probability of complement of A. Okay, so if I move up a little bit more, the probability of x greater than 2 is equal to 1 minus probability of x less equal to 2. That is equal to 1 minus in parenthesis P0 plus P1 plus P2. Now, when we are adding from 0 up to a certain number, there's a function in the TI-84 which is binom CDF. C stands for cumulative distribution function. That means we are adding from 0 up to a certain number. X is that last number. So it will be 1 minus binom CDF. N is 30. Probability of success is 0.59. And we are adding up to 2. So the last number is 2. How do I find the binom? So I do 1 minus, then I scroll down to second. I press on second, then I press the verse button, and then I scroll down to binom CDF. Okay, and then enter 30.59 and 2. Let's see what we get as the answer. So if I create some more space, that will be equal to equal to equal to 1 minus 1 minus second button, then worst button, then we scroll down to CDF, binomial CDF. Remember, CDF is used when we add probabilities from 0 up to a certain number. My number of trials is 30. My probability of success is 0.59, and I'm adding from 0 to 2. So my last X value is 2, which I enter in the calculator. Then I go to PEST. Whenever we are in PEST, we hit enter twice. And the answer is almost 1. Actually, let's write the answer correctly. Is 0. It is 0.999. Okay. So that's your answer for probability of X greater than 2. Okay. That's your answer. Okay. Now we will do the same part using normal approximation for binomial. Okay. Part C. Part C. Use normal approximation. Find EX greater than 2. This is X. Let me write that correctly. Find P of X greater than 2. Okay. Can we use normally? We can only use, so let me write it over here. We can use normal approximation if n times p and n times 1 minus p, n times 1, let me write that correctly, n times 1 minus p are both greater or equal to 10. So let's check in this case. In this case, n times p is equal to 30 times 0.59 is equal to 30 multiplied by 0.59 is 17.7, and n times 1 minus p is equal to 30 multiplied by 1 minus 0.59, which is equal to 30 multiplied by 1 minus 0.59 in parentheses is 12.3. So both of them are greater or equal to 10. Okay, so the conditions are satisfied. So I'll create some space. Okay. So the correction factor. So correction factor or correction. So write normal approximation to binomial binomial for Px greater than 2. Since 2 is not included, it will be equal to Px greater than 2 is equal to, almost equal to Px greater than 2.5. That is the calculation we will do, okay? Because 2 is not included, so the correction, this is the correction. Correction for using continuous probability distribution for binomial which is a discrete probability distribution. Now we need to know the mean and the standard deviation of this normal distribution. So let's move up. So the mean is mu is equal to n times p is equal to 30 multiplied by 0.59 is 17.7. And sigma, which is the standard deviation, is square root of n times p times 1 minus p. N times, that is a p. So how do I do it in my calculator? I'll press the second button, then x square button, that will give me the square root. Inside the square root, I will do 30, then multiplied by 0.59, then left parenthesis 1 minus 0.59. And that will be equal to, so first thing is second button, and x square button gives me the square root, then 30 times 0.59, then left parenthesis 1 minus 0.59, right parenthesis, and hit enter. And that's 2.693. So that is equal to 2.693. Okay. So we are assuming assume a normal distribution. Assume a normal distribution. Normal distribution with mu equal to 17.7 and sigma is 2.693. So if I create some more space, so probability of x greater than 2. I'll use my calculator. Second button, TI-84. Then verse button. Then number 2, which is normal CDF. Okay. My lower will be 2. I'm starting from 2 because I want probability, sorry, greater than 2 point, lower will be my mistake. It will be 2.5 because that's a correction factor I'm applying. So it is lower is 2.5. Upper is a very large number on the right, which is 1. Then second button, then comma button, which is on top of the 7 button, and that will give me the small capital E, which is exponent, 1E, and then I'll type 99. That means 1 followed by 99 zeros, which is my upper boundary, upper, okay? And then my mean is 17.7, and my sigma is 2.693. This, and then I will, of course, paste and paste. Okay, so paste. After that, I'll create some space. Last thing we do is bring the cursor on paste and hit enter and enter. Okay. Enter and enter, enter twice. I'll write enter twice. Enter. Press the enter button twice. Okay. So that will give us the probability of x greater than 2. And let's see how we get to it. Second verse 2, I'm starting from 2.5 because I'm applying my correction factor, and then upper is 1, then second button, then comma button, which gives me the E, then I type 99. My mean is 17.7. My standard deviation is 2.67, is 2.693. And I paste, enter, enter. And the answer is same as before, which we obtained by the binomial distribution, which is 0.999. So the answer from part B matches with the answer from part C, using the normal approximation to binomial distribution. Remember, I had to apply a correction factor since x greater than 2 does not really include 2. Therefore, the correction factor will start our calculation from 0.2 plus 0.5, that is 2.5. We calculate the mean of the binomial distribution. We calculate the sigma, standard deviation of the binomial distribution. These are the values we use as mean and standard deviation for the normal distribution. Okay, so I'll stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me thumbs up. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Okay, and do not miss any of my presentations because I cover all kinds of math problem. I'll be back next time with another interesting problem, interesting solution. And so do not miss it. Please come back next time. I'll see you next time. Take care. Have a nice day. Please keep watching my channel and subscribe to my channel.